That's crazy.
I why is Chauvin number
Is
one?
he A?
He's two.
His two?
We found out he's two.
Wait, what's his weighted GPA?
Lucas first? No, Miranda saw he saw Lucas as number two.
What's his GPA?
Oh.
What's the GPA?
Oh, yeah,
5.2 or
Damn.
Oh.
The
Fucking volleyball, bro. I'm dropping this flag.
the black hair glasses.
Wait, does he still have the?
You were way.
We take college on UF next year, 3.6.0.
Who?
You know
Right.
You will?
Yeah, he will. I was surprised. I was like, I told him, and he said he had. I was like, all right.
Watch you fail like us. You didn't do anything.
I didn't get my mom to contribute because she didn't like the idea. But I guess I'm chilling. I gave him the form. I was like, yeah, I don't have the signature.
I like when
Then I just told him what I wanted. He was like, okay.
You gotta take a Calc 3 differential equation.
Mhm.
Are you taking those? So you're taking 3 math though?
Hey, bro, I was reading 2.4. I had to reload also.
Okay, so first semester.
He's gonna take AP pre-calc.
No, I'm not taking stats. I'm taking AP stats.
Hey, you should take AP pre-calc, AP stats, Calc 3 differential equation, college algebra,
Like low key,
Let's check my.
only thing is I can't wait to see other.
Kappa,
that
everything.
would be so chill. That would be so chill. But I got, yeah, because I'm taking AP stats first semester, and then I have first semester I'm gonna take college algebra,
But if
and
I'm wearing
Calc
color or
3,
something, I just use
and then
it.
second semester I'm gonna take NDQ, and then probably nothing. So I'll only have 2 math classes second semester. There.
Take AP pre-calc.
Yeah, no,
But it's
I
like
don't
two
like
semester
having
class.
two like distinct sense like classes.
Can I just like AP pre-calc? Can I just like,
I don't know. It's like
can you just put me in like half a semester or 1 semester,
I don't know.
second semester?
Oh,
You're probably still gonna get. You're probably still gonna pass
I
that.
don't know, hanging out with my friends. It's kind of weird.
That's true.
Put me in AP.
Huh?
Put me in another AP class.
No, but I'll
Then
put
you're gonna be the same class as Sean.
Hang out with all my favorite sophomores. He's taking pre-calc.
like that on.
No. He probably gonna take AB again, right? Is he?
I mean, if he could, what would change?
Nothing will change. He's gonna flunk halfway.
Mystery, what's the difference between
They helped me lose my virginity.
What the hell, you guys? Can you stop? I'm live streaming, man.
Oh. For those listening, my name is Drago Brunke.
Uh, all right. Anyway, yeah. So we're gonna go to polar equation, and we're gonna talk about pre-calc stuff first, and we're gonna talk about calculus stuff. Calculus stuff is kind of interesting. So today we're gonna end with the slope of the polar equation, but we're gonna start with we have 2 type of things. We have r equal to a cosine theta, so you might want to write it down. And that a is gonna tell you a circle, and that circle is gonna place right halfway of the x-axis.
Wait, what does A tell you?
A is gonna tell you how big the radius is.
And then, wait, then what's R?
R is the polar function.
Oh, okay.
So do you see that is symmetry to x-axis? And that's going to be symmetry as x-axis. And if you have r sine theta, it's going to be symmetry to y-axis.
This is like, so when we're graphing like rectangular, we usually go left to right. Like f of 1 is this. So like say this was just r equals cosine theta, with like a is 1. So it's like the way you graph is like you say, all right, cosine of 0 is 1. So you go just 1 over, place a dot. Like, do you understand what I'm saying? Like you kind of just like go like.
Yeah, we kind of did that yesterday on other class. I didn't finish it, but I'll do that at the end. Is that okay?
Okay, yeah, sure. Yeah, how to actually. Like,
Yeah, so how to plug in the point.
yeah, how to actually.
So you plug in like a 0 first for radians, and you're gonna get an r as the output.
Then you just go that far.
And
place
then you
dot.
go and plug in pi over 6, and you see pi over 6. You go to line pi over 6, whatever result is gonna plug in another
Okay.
point. So that point keep on plug in until you complete the whole cycle. Okay, so this is RSine data. RSine data is the circle is on the top. Okay, and they have a symmetry to, we call it data equal to pi over 2. And that's RSine data.
What is the data equals pi over 2 mean?
This is pi over 2 here.
Oh.
So it has symmetry to y-axis. That's another way to think about it.
Theta equals 5/2 is for both of them.
No, this one is the polar x-axis. This polar axis is called x-axis.
So what is data equal?
So there's two type of symmetry. So right now we're gonna go in to talk about symmetries.
Wait, is there a polar y-axis?
No,
So it's just the y-axis.
either y-axis or data equal to pi over 2. But they are gonna be a pole. So remember that when we deal with a regular function, we have even function. What is even function? It's symmetry where? Even function is symmetry to where?
The y-axis.
Yes. And R function is symmetry to where?
X.
No.
Is it diagonal?
It's diagonal, but they don't call it diagonal. They call it symmetry to what? Origin. Okay, symmetry to origin. So I hear this is the first time you see a symmetry to x-axis. This is the first time you see symmetry to x-axis. Now, how do you tell if a polar function is symmetry to where? So in terms of even and odd, you can say, well, if I plug in that says f of negative x is go back to f of x, that's called even functions, right? Do you guys remember this? From pre-calc. And this is going to be symmetry to y-axis. And if you plug in f of negative x, if you plug in negative x into f of x, and if you got negative f of x, then that's going to be odd functions. And it's going to be symmetry to x-axis. So those are the things that we learned in the past before we learned polar. Now here we learn new thing. The new thing is, how can we tell are they symmetry to polar axis or data equal to pi over 2 or pole? Pole is known as, like a lot of people say it's pole. What is pole? Pole is the origin. Origin is, look at here. Does this like look like a pole here? This like look like the North Pole, where the origin is the North Pole. Okay,
You get the graph like that.
this is a polar equation.
Is there an option for that in Desmos?
Yeah. You just r equal to 3 cosine theta.
Like the circles.
They have a wrench.
Oh, this is options right here.
Oh, okay.
This is the grids. This is called polar grid. And
Yo, if you do polar, wait, is there like a 3D for polar? Like a sphere?
speak of which, I don't know because there's 3D decimals now.
Yeah.
I haven't played with that yet. I haven't tried with polar equation. So let me.
Like disc and wash method, but in polar.
I don't know. Hold on a second. Let's go to.
That could be tough.
Where's the 3D one? Right here. I don't know how the polar gonna look. Okay. No.
Whoa, it's like the electron thingy.
Yeah.
Wait, can you make it like a polar graph? Like in the settings?
Orbitals?
Yeah.
Yeah, or like that.
Oh, like the tools.
Yeah.
But this no difference though.
No,
This-
but like in the tools, when you change it. to-
where
Wait, click the box that says extended 3D.
where
The box under the equation.
Oh, yeah.
Yeah, yeah,
here?
yeah.
Okay,
No,
okay.
in the equation.
Oh, it's in 3D.
Yeah. Oh.
Whoa.
That, okay. Okay. Wait. Go to the little wrench like in the corner.
Uh-huh.
There.
I don't think this.
I think there's a grid.
I don't think this is really cool though.
There's nothing weird.
Wait, can you try x squared plus y squared with r squared? Like, would that be like kind of weird? Or z squared?
If you try y equal to x squared, it's already pretty interesting.
Yeah, I want to see something like weird.
There's nothing weird.
Yeah, like x squared plus y squared equals z squared.
You could like demonstrate this good washer and this one a lot easier, right? Because
Actually-
a slider.
Different variables.
Yeah, I want to see like it like be like weird like curving.
Be like a Z. Whoa.
Yeah, there it is.
Oh.
Squared.
Look, yeah, there's that.
Yo. That's
Oh, that's oh. Hey, no, wait.
We got it.
Oh, this definitely can teach Calc 3 a lot more better now.
Does Calc 3 do 3D?
Mm-hmm. The whole Calc 3 is focused on 3D. It's not 2D. So your integral is going to be integral respect to x, respect to y,
Yeah, it's
respect to
triple
z.
integral.
It's called triple integral.
Yeah,
Yeah, it's going to be a triple integral.
That's so
Uh,
Yeah, I got you there.
but he's gonna did it not
He's not a.
If we have the thing.
Man, I'll learn it with you guys. I'll learn Calc 3 with you guys. Jared,
Wait,
Yeah.
speaking of this good washer, can I get a little bit?
no.
Can I get a little bit?
It's more your calorie. It's too much for your calorie.
I'm not caring about the calories right now.
Huh? You're on a weight cut.
No, I'm on the boat. I'm both.
Yeah, I'm both.
I'm both. Look, I'm in 230 pounds right now.
Damn.
Just a little piece.
Jared, I'll take Calc 3 with you.
Yay.
Wait,
I think it's about
I'll take Calc 3 with you.
long though.
I don't remember. That was like 30 years ago.
That's good. And you can refresh your calculus knowledge.
Nothing right now. He says don't take linear algebra. But right now he's not doing it.
Him and Chris should go to the same level.
Obviously,
Well, did he take it?
he took it.
Yeah, no, Chris.
But the house is man not valedictorian.
Second, yeah.
Chris will take linear algebra.
So Krish is second. Now, why is Krish not second? Oh, Krish is even a year younger than her, right?
He's a junior.
Is your name?
He's saying yay. He's probably like third.
Somewhere in the top 10, probably.
No, Chauvin. I'm sorry, it doesn't deserve it.
Are you up there?
He just knew like the way around things. Yeah, no, he knew what to do. He's just grabbing all the GPA points.
Wait, you need Navy?
Yeah, he's in Navy.
Yeah, let me get a little piece.
No, I gotta do demonstration
Just
tomorrow.
one by-
Wait, yeah, with only party there.
Oh, that's fine.
Okay, so this is a how do you test? So let's start with this. Symmetry with respect to the polar axis. All you gotta do is replace the data with negative data. If it's equivalent equation result, the symmetry to x-axis. So if you plug in the data with negative data, and if you come out same result as before, then that you can say that's symmetry to polar axis.
Wait, this works with sine and cosine.
Yeah, but sine of negative data is equal to negative sine data. Cosine of negative data is actually cosine data because cosine's even functions. Look at the cosine graph, right? Start on the top. They have symmetry on both sides like this. So they are symmetry to y-axis. So they are even function. Cosine of negative data equal to cosine data. Sine of negative data is actually negative sine data. You didn't know that? You should know that.
I think need to process it.
That's okay. I'll help you review. So there are three different type of symmetry here. First symmetry is to polar axis, also known as x-axis. You just replace the negative data and to see what happened. Now, the second one is this one. Symmetry respect to line theta equal to pi over 2, which is y-axis. How do you know that? You replace the r and theta at the same time. You place both negative r and negative theta. And if you come out same equation as before, they are symmetry to y-axis.
Negative r and negative theta?
Yep.
That's the same thing as negative theta becoming negative.
I don't think you can call it R function, but it's, you do have a symmetry. So there are three different type of symmetry, not like odd and even. Odd and even is only two type of symmetry, with symmetry to y-axis and symmetry to origin. This one has a one extra one, which is this one, symmetry to x-axis. This one, symmetry to y-axis, you already have a normal function. The last one is symmetry to the pole. You can have symmetry respect to the pole, which is also known as origin. How do you know if symmetry to origin? You replace r with a negative r. If they both equal to, then you have symmetry to pole. Yeah.
How would that work out?
Well, you gotta try. So every equation, polar equation, you can test trial, see which thing are they symmetry of. Now, for example, I'm gonna show you that it's very, very deceiving that people might think something is symmetry to both x-axis and y-axis at the same time, but that's not entirely true, because you look at this, you see this, right? Let's start with the sun. Let's start with sun, and let's say 2 theta. That looks like it's symmetry both x-axis and y-axis. But that's not entirely true, because if I change 2 to 3, they only symmetry to y-axis. It just happened to they show us the symmetry there, but doesn't mean they are symmetry to y-axis. They are actually for the prior case for 2, they actually symmetry to so if you look at here, they actually symmetry to y-axis instead of, it looks like it's both, but it's not. It's still only y-axis. Because when you test it, this function, it's only going to be symmetry to y-axis. Because you plug in negative r, and sign of negative theta, it's going to give you, they both are negative sign, so they will change both positive sign. So they actually only symmetry to y-axis. Some people say, oh yeah, there's symmetry to origin, and there's symmetry to y-axis, and there's symmetry to x-axis. No. They only symmetry to y-axis in this particular case.
So you can't look at a graph and tell if it's.
You can, it's deceiving.
What's the pole? Like what?
Pole is, we're gonna show you the one I look at, but I'm gonna show you cosine now. So if I have cosine, right? Again, it looks like it's symmetry to all the things, but it's not, because if you go to the 3, you can tell that has a specific symmetries. It's symmetry to x-axis for cosine. And then not only that, they retrace twice. They retrace the graph twice. Now to show you that okay, to show you that I think Daniel want to see what it look like. Okay, so what I'm gonna do is I'm gonna do 0. Now instead of graphing, I figure out a way, since you asking that question, it made me think. I can change the step to pi over 6. And I can do Does that make sense?
Well, like the process of actually graphs is so challenging.
Where you doing it?
So let me change the step to the pi over 12, maybe better.
Well, you don't need steps.
No, but I want to. He said he want to see how the plugin work.
Like, Anthony, so R is the same as Y. So if you plug in data, then you get like a Y value. And then you
This
can-
is how the thing look.
It's kind of weird.
We need to learn how to graph these. Like,
No, you use the thing. I'm not gonna ask you to graph this by hand. It's ridiculous. But in usually like in like Chaparral's class, if he got to that far, then we're gonna ask students that, hey, let's graph one. Like today is like nobody showing up, and let's graph it together and just see how the formation is. But this is probably much easier way to see how the formation is. Let me see if I can pause in sometimes.
Wait, yeah. So cosine is always going to be symmetrical to the x-axis. It's r equals cosine theta. Or do you have to always, or do you have to?
You had to test it. But in this case, if you're plugging native data and native R, yeah, it's gonna be symmetry to y-axis. Okay, so this is pi over 12. If I plug in pi over 12 in there, right?
Yeah. Okay.
So it's gonna be 3 pi over 12. What is 3 pi over 12?
oh, 5/4.
Pi over 4. So it'll be 3
Square root.
times square root 2 over 2.
Uh-huh.
What's 3 times? So it's a half times 1.4. No. Yeah, so you can see that it's going like almost a little bit more than 2. Hold on a second. 4
Let me see.
square root 2 over 2. Okay, 3 square root 2 over 2.
0.70. I can see. That's
So that is almost, do you see that this part is almost like this? Almost this value right here?
Oh, it's the exact value. 3 times square root 2 over 2 is 2.1.
And what are we talking about?
2.10. See that 2.10? You see this is 2, radius is 2,
Yeah.
2.1 something.
Oh, okay.
Do you
So
see that?
You place that dot there.
Yeah, you place that dot, each individual dot.
At each
Oh,
radius.
is this how we graph it?
Yeah.
Alright, I kind of.
And the second dot is going to go back to the 0, right? Third dot is going to go to the other side. It's negative 2 point. It's probably negative 2 point something, but is you facing the pi over 4, but it's going to be negative r. So you go across the other side to graph that point.
Yeah.
So yeah, so this just how the trace line of this going to happen.
Yeah. Okay.
Does that make sense?
Mhm.
So I want to ask you, which kind of graph is this symmetry of? R equal to 1 minus cosine theta. Try out different 3 things. You can see, okay, which one is symmetry? Is symmetry to pole or symmetry to pi over 2?
Oh, so much shit.
Symmetry to x?
X is pole, right?
Okay, symmetry to polar x. Polar axis.
Yeah, polar axis.
Yeah.
Polar axis. Yes, because you plug in negative data in here, it's still going to be cosine theta. It's going to be 1 minus cosine theta, where same as before. So I will show you what happened if I did. This one is symmetry to polar axis, right? Because I plug in negative data. Now, what if I replace the r and theta at the same time, which is as a test for if they are symmetry to y equal to pi. If I do that, do you see that if I plug in negative r and 1 minus cosine negative theta, that's going to be negative r equal to 1 minus cosine theta. And that times both sides by r negative, then it's going to be r equal to cosine theta minus 1. This is not exactly the same representation as before. It's actually opposite. So this is not a symmetry. You're going to plug in pole, which is you replace the r with a negative r. And that result's going to give you the same thing when you do theta equal to pi over 2, because you got r equal to cosine theta minus 1. It's not 1 minus cosine theta. So they are only in symmetry to pole. Is that okay? No, symmetry to, sorry, polar axis.
Okay, wait, but that's different from what the original one was.
Yeah, it's different, so they are not symmetry.
Oh, okay. Wait, sorry, I'm not gonna lie. I kind of guessed when I said symmetry to x-axis. How did how did you get the negative data to be not negative?
Okay, so-
Can I try?
Yeah, go ahead.
So here, Rob, imagine. I want you to imagine.
Why can't they
high
do
over
X?
Yeah, I know. It like
Why do they have to do polar X?
So imagine
Because
how-
now, right now, we're just gonna translate all the name to
cosine
polar,
x here. How
polar
about
name.
negative pi over 4?
Um,
To go down.
so in polar,
Cosine, the x will be the same.
like instead
Oh,
of saying, like
That-
in parametric, we have different name for that too.
Yo,
In parametric, we don't call it a R, the distance to the pole. In the parametric, we actually call it a magnitude. How strong they are. It's the magnitude. Or
Parametric and polar.
huh?
Parametric and polar are the same thing.
They are different.
I need to get my
Like, what's the difference?
We're gonna get to parametric.
But you call it y-axis and polar, right?
Have you heard that?
Yeah. So parametric usually we introduce another. It's a little bit. It's almost same, but it's different because we introduce as you know, x equal to phi t, y equal to t squared. So if we plug in t equal to 1, then you got two different x and y. T equal to 2, you got two different x and you got another x and y coordinates.
So negative 3.
So we kind of had to do that here, but we're gonna get to there when we get there. But right now we're just gonna focus on polar, because usually we will say x equal to 4t, y equal to t squared. Then if t equal to 1, then you're gonna get 4 comma 1. And t equal to 2, then it's gonna be what? 8 comma 4. Does that make sense? We have another variable here, t, and we can plug in the t.
What is T?
Later on, we're gonna get there. So we're just gonna introduce that. So they're just two different things. So it's like, for example, like maybe like if you're doing it with physics, t is gonna be time, because you got what? You got sine of data, sine of time, sine of the data is gonna be, when does that happen, right? The angle is going to constantly changing when you're doing projectile. So. Do you have to drink it like that?
Don't joke. Don't joke, bro. Don't joke.
Does that increase your lung capacity or something? I don't know.
Impulse thought. Intrusive thought.
Wait, but if you grab it, can you grab 1 minus cosine theta?
No,
Yeah, of course.
You need to fill it out.
This is what Bob was asking. Like, what is the
Wait, did it for?
Yeah. Like, if we have symmetry against about the pole, like, where is it symmetrical against? Is it like a diagonal, like pi over 2, or pi over 4?
I'll show you the graph.
Yeah.
You don't have to do like the back and forth. You can show the whole thing.
Okay.
It would be the same.
I'll just do 2 pi and without the steps.
Bro, one of the symmetries being polar and the other one
Like a cardioid. Or they-
Cardiograph.
So like, where is the pole aligned? Is it a dot?
It wouldn't make sense.
This is not. This is a symmetry to polar axis.
Yeah, but can you show us symmetry against the pole? Because I want to see like where it's like.
Oh, we're gonna show you one. Don't worry. We're gonna get there.
Okay.
Okay, so this is Can you tell me which kind of symmetry is this?
I imagine it's symmetry against the pole.
I got you. All right. It obviously has y-axis symmetry since it's a sine graph. Wait. It's sine of 2 theta. Do we have to do a power reduce?
No. Just replace the data with negative data, and then replace r with negative r,
How do you do R?
and then replace. So usually you replace the data with negative data, or replace r and data at the same time, or replace the r.
I think it's gonna have symmetry about the polar. No, I'm sorry, the y-axis and the pole, but not the polar axis.
Actually, you're wrong.
So it's not
It's like,
symmetrical
make this R,
about
dude,
the pole.
and you divide it over. Obviously,
No,
it's gonna be a-
because
Wait,
if
I'm
it's a
correct?
pole, then I just replace R with a negative R.
Yeah, yeah.
So that will be R equal to negative 4 sine 2 theta.
So it's
So
not-
that's not.
Okay, yeah, I think that. I'm like that. Bro, I'm
Oh,
cooking
are we
today.
doing this right now?
Yeah, we will see which kind of symmetry is this.
Can you do the same thing for sun?
Wait, let's see.
It-
I don't understand the one with the
Yeah.
origin. Because if you're just gonna make R negative,
Like try power two.
you're gonna like distribute the or divide it by negative.
I'll show you the one with pole. Now this one is what? There was y-axis. You're right.
Right.
Theta equal to pi over 2. Okay, so
Wait,
you-
wait. Okay. It's not symmetrical at all. No, it's symmetrical with respect.
That should not make no sense.
Hold on, I forgot the names. It's symmetrical with respect to the polar axis.
no.
Exactly. What?
Because the polar axis, you replace the theta with the negative theta. So you're gonna say 4 sine of 2 negative theta. And then that's gonna give you R equal to 4 sine of 2 theta. So that's not it. So this is not polar. So
But I
polar
thought it
axis,
was- Why doesn't it become negative
It's
2
just like
theta?
this.
huh?
Why doesn't it become negative 2 theta?
R equals square root.
Like
that's the
sine
thing,
of
right?
negative 2 theta.
You can, but that's gonna give you positive here, and you can
Okay, but
replace
like,
it outside.
How can you just move it to the outside?
Because sine of, that's a good question. Sine of negative theta is equal to sine of theta negative. Cosine of negative theta is equal to
Oh, okay.
cosine of theta. That's it.
Then if you
So this is called a
Okay,
even.
So then it's symmetry with respect against the pole. With
No.
respect to- yeah, because
It's not
negative
pole.
R.
Because a pole is, if you
And if you
okay.
replace both with negative, so then it would move.
So if you replace both,
Then the
yeah,
R
so
would cancel out.
if a theta equal to pi over 2, then you replace the r with negative r. 4 sine of 2 theta negative. So that's equal to negative 4 sine 2 theta.
Yeah, and then it would be the same. That's what I said. Let's go, brah. I'm like that.
I have a question.
Okay.
So is R equals sine theta symmetrical about the pole?
R equal to sine theta. Is that symmetric to the pole? No.
Just y-axis? So
Just y-axis, yes.
symmetrical about the pole, rotational symmetry, like about the origin?
Yeah, origin.
Okay.
So I will show you the symmetry to origin. This one is r squared equal to 4 sine of 2 theta. So this one's the symmetry to origin.
No, but
Wait.
if you're to solve for the R though, like
No, this one you want to plug in. You want to, so symmetry to the pole is you replace the r with a negative r. So I hear if you replace the r with a negative r, just go back to square.
But wouldn't you also have to replace the theta with negative?
No, that's not the condition for symmetry to the pole.
Or it'd be symmetry against the pole.
But didn't
Look,
you-
if symmetry to the pole is only replace r with a negative r.
Wait, go up and to the right.
That was you
Yeah. You replace both. Oh,
wait, but like if you're
Yeah, but you cannot replace both of them
Monsieur,
because you replace both of them, the right side becomes negative.
but for the one above, you replace
Yeah, the
for
one
the one
above
above.
that one is pole.
The R equals sine. Okay, R equals 4 or whatever the hell it was.
So
Replace both of them?
Yeah.
yeah.
Because then the negative comes out of the equation and it cancels out with the negative on the R.
Wait, so
I mean, that's what
if
he
you're
said.
trying, but
But
you're gonna
like-
be trying to solve for the
Because
for
it's
R,
like-
right?
hold
So
on,
wouldn't
what
you
you said.
simplify?
no,
We
you're gonna keep it like that. You're gonna say r squared.
So if it's ever R squared, it's always gonna be.
So I'll show you what a r squared look like.
Ooh, that's fine.
We're not supposed to.
I know.
R square, hold on a second, I don't know. Hopefully they can graph. What was the equation? R square equal to 4 sine theta?
4 times 2 theta.
4 sine 2 theta?
The negative can move alpha.
What is that?
That's a theta.
Actually, it doesn't graph.
Huh. 'Cause I think you're supposed to solve for R.
Yeah.
No.
Only does it R is by itself.
Dude,
Yeah.
Only the decimal only do it by itself, but
So
the actual
like-
graph is gonna look like something like.
Just square root of it.
Yeah, what if
You
it's
wanna just
square root?
do okay? All right, just do that.
Yo,
And you
yo,
can have-
I got it. And then the negatives cancel out.
Wait, why is not able to graph?
That shit. I solved this upside down.
So it's gonna be R both.
Apparently, I'm too short.
Yeah, but why it doesn't do that? Huh? Oh, I forgot a square root. You're right.
I do not want short. Shorter than me, it feels like I'm fucking a kid, bro. It's like,
Also,
Couldn't it be negative though?
Wait,
Like
it's
you just solve it for R.
He's
No?
I don't know. Like,
You're strong enough.
You can do negative. It doesn't matter.
need.
You cannot. Oh wait. Can you do negative? Yeah, you can do.
Yeah.
Negative.
It's outside the square.
Negative square root.
She's like about my height. I remember when I was working with her. We worked at Aquatica together,
It's the same graph.
so I had my shirt off. That's like when I was extremely fat. So, okay.
Same
Oh,
graph.
but yeah, you're recently.
Yeah.
But if you, if you're solving for R though, like it would be plus minus.
It's my
no?
Instagram.
How do you
It's the
know?
same graph.
So you can choose either or.
So this is a symmetry to origin. This is the only one that's symmetry to pole. Okay, we gotta go to other stuff. Sorry, we spent too much time on this. We have 7 minutes to do the rest of them. So what we're gonna talk about is today is gonna be this slope of tangent line of polar axis. So this is something that you have to know. So this is the calculus. All the stuff we've done is pre-calculus. We just need to build that. So next time when you go to take Calc 3, the teacher is not gonna be like, you don't know anything. You should drop this class. So you should have some pre-foundation of certain things. The pre-calculus is actually known as prepare for Calc 1, 2, and 3. It's not just prepare for Calc 1. So people thought pre-calculus is prepare for Calc 1. It's not. It's a preparation for Calc 1, 2, and 3. So that's why you got matrices and stuff like that in the correct.
We did not learn matrices.
Never. Oh, we were supposed
You
to
gotta learn matrices to freak out.
I
I
know.
learned matrices for my SAT tutor. I've never seen those before.
You have SAT tutor?
I did for
I don't think Shaparo shot matrices.
We learned it a little bit.
matrices are whack.
I thought yes did not do that.
They're whack.
All right. So dy dx is known as the dy d data over dx d data. You can see that d data is going to go away. Now, what we're going to do is going to start with the x equal to r cosine theta, right? That is the polar equation. Is this okay? So we can change the r to becomes like in terms of function. It'll be f of theta. Is that okay?
Yeah.
F theta cosine theta. Y is equal to R sine theta. So there will be F theta sine theta. Now, what I can do is I can do this on the top. I can take a derivative of that. If I take a derivative of that, it's going to be a product rule. It will look like this.
Yo.
I bet. Keep running.
What the hell?
I take a product rule because I replace this R with the F theta. And then I'll just take a product rule. So on the bottom, it's going to be your X. So I take a derivative cosine, it's going to negative sign.
Would it be
So it'll be
minus on the top?
Y. The top part is a Y.
Yeah. But like for the top part, wouldn't it be cosine theta plus f or minus f times sine theta?
Are you thinking about Portugal?
No, the top is you're going to take a derivative sine theta. So it's cosine theta. So it'll be F theta cosine theta. And then you're going to take a derivative of the F theta. So
Oh,
F
okay,
prime
okay,
theta
okay.
sine
Yes,
theta.
yes, yes.
So is that okay?
Yeah.
Now, this is the part that you gotta understand. Shh. This is the part that you gotta understand for today's homework, which is you're gonna have dyd data is equal to 0 is known as a horizontal tangent. If dyd data is the horizontal tangent. Now assume that dx data, provided dxd data is not equal to 0.
Wait, can you explain that better?
Okay. Provided that dxd data is not equal to 0, because that's the bottom, right?
Okay.
Remember dxd data is right here. It's not equal to 0, but dyd data is equal to 0. Therefore, it's a horizontal tangent. Just like when we, a long time ago, we said dy dx is equal to 0. That is a horizontal tangent. Except now we said dyd data instead of dy dx.
So if dy over d theta equals 0, there's a horizontal tangent.
Yeah, and provided dxd data is not equal to 0, because equal to 0 is undefined. You cannot both equal to 0 over 0. If it's 0 over 0, 0 over 0 is indeterminate. Now, if dxd data is equal to 0, then it's also known as a vertical tangent. So your objective is to find this. If I give you a polar function, r equals sine theta, can you find horizontal tangent line and vertical tangent line? So you guys need to do that one.
Sure.
Do y'all know where to start with this? Like I think I kind of have a way to explain it.
So R is F data.
Yes.
Here, wait, you try it. You try to convert r equals sine theta, then find the horizontal tangent.
No X.
That's the thing, right? There's no x or like.
Okay. Multiply with that by R, you get X squared plus Y squared equals Y.
No, I think you think too complicated.
So I think like here's how I think about this, right? So remember the formula is x equals r cosine theta, y equals r sine theta. Like I feel like there's like the links to get into derivative form. Like you substitute r into that, then you solve for x or y, take the derivative, and then plug in, and then solve equals 0. Does that make sense? So you do two different things. So you use those two formulas, like convert it into derivative.
Not only that, you can find dy dx on particular coordinate, but you have to plug in
Data or
Can,
data.
can I just convert?
I'll scroll up.
Oh, wait.
These two formulas.
Oh, y equals 1.
No.
Wait, F of theta is just sine theta. So if we can plug everything into that dy over dx equation, then equals to 0.
Wait, what is F?
Yeah, equals to 0. So we would have sine times cosine plus.
Yeah, F of theta. That's just R?
Yeah, okay, so
Yeah, not- yeah, exactly.
It's just whenever you solve
Right?
for R.
Yeah, you put like
R is
derivative.
So we need when sine is equal to 0 and when cosine is equal to 0. The
So I'll show you how to go to the first step. The first step is write down x equal to r cosine theta, y equal to r sine theta. I'll replace the r with sine theta. I'll replace the r on sine theta. So they give me a two separate equation. X is equal to sine cosine theta, cosine theta, and y equal to sine squared theta. So I'll take a derivative and I set it equal to 0. I take a derivative, I set it equal to 0. I find out my horizontal tangent and I find out my vertical tangent. Take a picture. If you don't understand them, you gotta understand them. It's the best you understand them before you leave, though. Rip up, understand before you leave. I know you rush to go. You have a date to go to.
No, I have to get my hair cut. I gotta get my shit lined up.
Where you going, bro?
Next
Next
month,
month,
bro? Yeah.
I'll line you up. Make sure you got scissors.
Scissors.
Just get a buzzer.
Straight down the middle.
You're definitely gonna leave an impression there.
Yeah.
Oh, you have to find both the vertical and the horizontal for the whole.
No, you do the reverse.
Hey, bro. This is, yeah, you remember that? I talked to Jeff, bro. I'm not the algorithm.
Alright, then you would be so drippy with it. Like, in all seriousness, like.
So the horizontal tangents are at pi over
So you had to plug in to get a value too. You had to plug in the pi over 4 to get a value as well. So it'd be r cosine theta. So you had to plug in.
Oh.
Yeah, we got four at a time.
Yes, because it was, we didn't make the same mistake. Simple mistake.
So I gotta take my.
But no, he got 9 down.
Oh, so the horizontal. Wait, what? Oh, okay. So the horizontal tangent at pi over 4, right? Pi over 4 and 3 pi over 4.
Yeah.
And the vertical tangent's at 0.
Yeah, and you had to solve. You had to solve for r too. So when you do that, you had to solve for r. So and that's it.
Wait, what do you mean solve for R? Wait, yeah, what do you mean solve for R?
You had to plug in. You had to plug in
Oh,
r equal to sine theta. So once you find out there's pi over 4 in here, so that's sine of pi over 4. So it'd be square root 2 over 2. So it'd be square root 2 comma this is your r. Theta is going to be pi over 4. So that's where your vertical tangent. I did forgot to do that
yeah,
earlier.
vertical tangents.
That's where the vertical tangent occurred.
Put it like that.
Because this is a polar coordinate.
Oh. Oh, yeah, yeah. But what about
Why
three
is
pi
he
over-
yelling? Why are you yelling?
Because I just talked to Brandon else all.
What about 3?
Yeah, guess what's my class ranking?
Nobody give a shit.
I'm number 2. Yeah.
No one cares about class ranking. I don't care.
If you cosine pi over 2, which is like right in the.
Oh, which is not.
Yeah.
Did you do your homework?
Yep.
You got
Now.
You messed up a lot, bro.
Wait, sine of pi over 4 is the same, right? Sine theta over 4. Yeah, no, it's just one. Yeah, because it always yeah, it'll be sine pi over 2.
Nothing. Don't look at it. Don't look at it. I'm gonna stab your eye.
We just looking at
Except I'm gonna stab both. Why not? Why not?
Yeah, nowadays, like, no, 3 years I've been
My
going.
GPA is my own.
I can even fall asleep at 7.
I sacrificed. I sacrificed.
See, 65. My GPA.
4.5. I got this class. I got sick. Right now, let's go.
She was here.
Oh,
Y'all have so much fun. Yeah. It was easy. Actually. Oh yeah, but she has to do some worksheets and stuff that she's not here. We didn't get
what is what's your
right here. What did they do like notes in class? We do like you know the ghost cases.
Either you're smart or
We
you're not.
do those. Like just like the required outside.
Austin, go talk to Parati. You gotta graduate. Go talk to him. Just say, look, I'm messed up on these classes, and what should I do? And then take your hope online, please. And have it Spanish.
What Spanish did you take? Oh, we can take that so we can. It's only one.
Just make sure you understand everything before you go there. I don't have homework today. I don't have homework today. If you finished yesterday, but make sure you understand it though.
Bro, how long did you do that? Yeah, we still have.
Just make sure you watch it. Like, you have.
We have subject. But like, I'll.
Oh, we never even looked at it.
I got something like, they can't be.
Well, at least you did. Bro, how could they do that on the test? You do all that. It won't even help you. We're about to finish with it. I knew Bill would be easier. I'm better at technical. I knew Bill would be easier. Everything at Maxwell first.
Really?
No, wait.
No, I got that.
Yeah, it's
Oh, because I did yeah, I did have to swear it instead of use that right there.
Let me show you the 9 rules.
Oh, the night. Yeah, some of them last Saturday.
Did I show them?
Yeah,
They're all